Welcome students. In this particular class we are going to be writing a Python code to actually calculate the area of the shaded region. Now in this case we are looking to find the area of this region. Now let me change the color. I will place in yellow color. So I would like to know the area of this entire region. Now if you were to see this figure is a triangle. Now inside the triangle there are a few important informations we need to make, or I should say take into account. First, the triangle has got two triangles and a huge quadrilateral and also a circle. Now it is given that DOE, which is the diameter, is 14 units. So if DOE is 14 units, then OF is going to be 7 units. Now we have been given on this figure OF is equal to FB, so an isosceles triangle. So this side is same as this side. So FB, if I can write over here, FB is same as OF, which is equal to 7. Why do I say 7? Because it is the radius of the semicircle, and we have been given the diameter DOE is 14 units, so the radius is going to be 7 units. Okay, fair enough. So I can literally place 7 units there and move on. Now since the side OF and FB are isosceles, they will make the same base angle. They will have a same base angle. So what I wish to do is I would like to take that base angle to be as alpha. If this is alpha, then this is also going to be alpha. Let me, okay. Now having got that, we would have to find out alpha. Now why would I need alpha? Because I need to get the value of theta. Now you might be asking me, why do I need the value of theta? Because we need to get the shaded region. Now since I mentioned to you that this shaded region is actually a quadrilateral, so the required area will be equal to the area of the quadrilateral. Let me write that down. Area of the quadrilateral. And now what is the quadrilateral we are talking about? It's going to be GCFO, right? So from that we need to subtract the area of the sector. So the area of the sector is going to be HOF. So let me write that, HOF, right? Now to get the area of the sector, I need to get the value of theta. To get the value of theta, I need alpha. Not only that, I need to know what exactly is existing in this side, this angle. Okay, so we would have to calculate alpha. Now before we could go on to calculate alpha, you can clearly see that this side is hitting the tangent at F. There is a tangency here that is created when the side of the triangle is touching the circle. Now whenever you draw a line from O to the tangent, that would make an angle of 90 degree. Now please remember, the code that we are going to write will take into account this shape. In other words, this shape ought to exist. In other words, what I wish to say is there should be a tangency here. It doesn't matter if this is 90 degree or here, 90 degree or not. In this question, we have been given here as 90 degree. Now for the Python code, it doesn't matter whether angle at C is 90 degree or not. We can take in any angle for that matter. But for this particular application which we are designing, we are taking into account that this angle is 90. In other words, there is a tangency that is existing between the circle and the side of the triangle, right? So having mentioned that, what we will do is we will calculate the angle alpha. We will write a code to calculate the angle alpha, and then we will move on to calculate this angle. Now what is this angle? Now clearly you can see that there is an isosceles triangle existing here. We have AG which is equal to GO, and we are also given that GH is equal to 5 units. However, since GA and GO are equal, they will be making same base angle. Now I'm going to take this base angle as say some beta, right? If this is beta, this one is also going to be beta. Now I can easily get beta from here. How do I get beta? Just alpha plus beta plus 90 is going to be equal to 180. So I will be writing a code asking the user to give me this angle. In this case it's 90, but according to the Python code it can be anything. Now since I'm actually restricted with regard to the board and the writing ability, what I will do is I will place in a link where I have used pen and paper to exactly write the solution for this particular question, and I will also place the link so you can actually see that what is exactly existing. So I mentioned that this would be my objective. So let me get my objective clear. My objective would be from the area of the quadrilateral, I will have to get the area of the quadrilateral. From the area of the quadrilateral, I will take away the area of the sector. So let us do that, and that would give us the area of the required yellow region, which you see here. So let me go to PyCharm. So in PyCharm, what I'm going to do is I'm going to import a math module. I'm going to say import the math module, and then I'm going to define a function. So df is going to be angle calculator. Now which angle I'm going to calculate? I would be calculating this angle, the alpha here. So that would be the code that we will be writing now. So I'm going to take some parameter. I'm creating a function there. So I'm going to give, I'll explain to you within a minute, is equal to 180 minus degree 2 divided by 2. And then I'm going to say return unknown underscore degree 1. Okay, so what am I doing here? We are actually getting the value of alpha that you see here. This value will be obtained. So to get that value, what I need to do is I need to add up these two alphas that you see here, and then this 90. Actually some of these angles lead me up to 180 degrees. So from 180 I need to subtract this angle, in this case it's going to be 90, and then I need to divide the outcome by 2 because of the reason that it is 2 alpha, right? That's exactly what I'm going to do. So first let me actually give a print statement. Print, we will get the value of alpha now, right? So for that, probably I will say which is in the isosceles triangle. Okay, so we say degree underscore input. Now we are actually getting that 90 degree there. Now there can be an issue also in case you are handling a figure where that angle is not 90 degree. It doesn't matter, right? So we can just take in that input. So int input, please enter the angle that is unique, right? That angle is different. That is unique. Okay, so we got that angle. Now after we have got that angle, we need to call the function. We need to call this function. So as I mentioned to you, we are actually passing this over here From 180 it would be subtracted and divided by 2 and it would be returned to us. So that's the simple logic there. So this is the alpha degree, which is equal to, I am calling this function, right, and inside this function I'm going to send in this input. So that's it, story done. Okay, now we need to calculate, let me move over here, we need to calculate beta. Now alpha is found, right, alpha is got from here, we have got the value of alpha. Now after getting the value of alpha, I need to get the value of beta. Now already I know this angle is 90 degrees, but it doesn't matter, it can be any angle for that case, right? So because we are writing a Python code that will target any angle. So let me design a function. So it's going to be angle, let me just give your angle calculator 1, and for this I will just copy this out and say angle calculator 2, and then I will send in a degree, and the unknown degree, it's beta here, right, 180 minus, from 180 I need to take away the degree input, whichever degree we are giving. So I will just write that down, I'm sending the value there. So degree underscore input plus alpha degree, this is already got, and that's it. So that would give us the output. So in this case we will say return degree 2, and we need to write a function for this. So in this case I'm going to give a print, we will now calculate the beta degree that we have in the figure, right? So in this case what I wish to do, I will have to get that get the degree input. So I will actually get it here, degree input, degree underscore input 2 is equal to int. As I mentioned to you, it can be any degree, but in this case we are having a 90 degree there. I'm actually typecasting, right, because whenever we receive input it will be in string format, so we need to typecast it. So int input, please enter the known degree that you see in the triangle. So that is got, and then after we have got that, we will, that's a beta angle, right? So beta underscore angle is equal to, I need to call this angle calculator function. So angle calculator 2 is called, and the degree has to be sent in. So degree input is sent in. So over here, so you can just place degree 3 there. Okay, so whatever information that you're getting, you're passing it as a parameter and calling the function, and then once you call this function, the parameter is substituted here, and the alpha degree which we have already calculated, that one is utilized here. So these two values are summed up and subtracted from 180 to give us the beta value. So the beta value is returned and it is stored in this variable. Okay, so let me go back to the picture. So we have got beta, we have got alpha. Now we need to get the value of theta, right? So how are we going to get the value of theta? So let me go back to the PyCharm and then say theta angle, theta underscore angle is equal to, from 180 degrees we subtract alpha degree added with beta degree, right? Beta angle, alpha degree, beta angle. In fact, I will just replace it as angle, alpha angle and beta angle. Okay, so this has given us the theta angle. Now we need to get the radius of the circle. All right, all this information are there in the figure. So I will simply say radius input is equal to int. So that would mean in this program we could actually run this application for any given circle, right? So please enter the radius of the circle. So radius is got. Now we need to get the sector area. So I'm going to calculate the sector area is equal to, now it's going to be theta angle that we have got divided by 360, place it within parentheses, and then pi r squared. So for that we have already imported the math, right? The math module is imported. So this into math.pi, pi r squared multiplied, it should be math there, right? Math.pi multiplied with radius times radius, pi r squared. Okay, that's fine. So we got that. And then if you want, you can actually print it here. Print the area of the sector is equal to, comma, sector area, right? Now this is theta angle. Okay, so that's fine. Now sector area is got. Now it's time for us to get the area of the quadrilateral. So I'm going to say print, we will calculate the area of the quadrilateral using Bretschneider's formula, right? That's a formula we'll be using. Now, as I mentioned to you, I have worked out this question using chalk and talk. So please watch that video. So side 1, I'm going to say int of input. Please enter the value for side 1. That's got, and I'm going to copy this. I will paste it. Then I will change it to side 2, side 3, side 4, and then this is side 2, side 3, side 4. So all of these sides are got. Now we need to utilize the formula, right? So the formula is, first we need to calculate the perimeter. So I'm going to say S is equal to side 1 plus side 2 plus side 3 side 4. So the perimeter is obtained and is divided by 2. That is the value of S. And then the area formula. Area is equal to math dot sqrt of S negative side 1. This is multiplied with S negative side 2. This is multiplied with S negative side 3. This is multiplied with S negative side 4, right? Fair enough. So that would give us the area of the quadrilateral. In fact, you can print the area of the calculated, the area, I can say calculated for the quadrilateral is equal to area. That's a variable name, right? Now we need to calculate the required area. So probably we can say print an asterisk and then give a pattern, say 30. There'll be a demarcation line. Now required area, we need to calculate the required area. So required area is equal to area of the quadrilateral. So from the area we subtract sector area, and then we say print the area of the yellow shaded region is equal to required area, right? So that is the code, and we will save it, and if in case we got any error we will have to look into that. Now I see that I have changed it into alpha angle, and that has to be placed there. So this is the code. We calculate alpha, we calculate beta, and then so on and so forth. So I'm saving it, and then I'll run it. If there is any issues, we will have to come back. So let's see. We will get the value of alpha now, which is in the isosceles triangle. Please enter the angle that is unique. So in this case, we are looking into this angle at F, and I know that is 90 degrees because from the figure it's visible. So we will enter that angle as 90. We will now calculate the beta degree that we have in the figure. So this beta is calculated. So beta is calculated. How are we calculating beta? Beta plus alpha plus this angle at C 90 will be equal to 180. So from 180 you take away this angle. This angle at C can be anything along with the angle at alpha. So that will give me beta. So please enter the known degree that you see in the triangle. So that's 90 degree, right? Please enter the radius of the circle as a spell check. I need to refine that. The radius is 7 units. It's seen, right? Radius, you can see that 7 units. So enter 7 units. And then area, this is the area of the sector. Okay, fair enough. Now please enter, we will calculate the quadrilateral using Bretschneider's formula. Please enter side 1. Side 1 is 12 units. If you are not sure, you can actually check it out, right? All of these sides are given. Now this side is also given here. You see AG is nothing but GO. Both of them are equal. So GO is 5 positive 7, that's 12. So that's why AG is going to be 12 units. So this is side 1 is 12 units, side 2 is 3 units, side 3 is 8 units, and the last side is 7 units. Now all of these sides are actually extracted. You see 3 and this one would be 8, and the last side, which is the radius, is 7 units. So that's why I given 7 units. So a quadrilateral area is this, and the area of the shaded region is this 6.4153, and so on and so forth. This is exactly the solution that I have produced. So this is a lovely program written in Python. Students, I hope you have enjoyed this. Until we meet again next time, thank you.